All right, so let's come back to the tutorial. Now, if you look at the first question, which of the following shows definition of power and the SI unit correctly?
Man, why is it not B?
You're not showing, yeah. You're not seeing my slides, huh?
No, not anymore.
Can you see?
Yeah.
Can see, yeah. Okay, good. You have a question for me about this?
Not B for Belgium?
Why is it not B? Because the unit is obviously not correct. Right? We are talking about power.
I thought it was ampere that was current.
Huh?
Ampere
is not current, that's true. But they're asking for the SI. Yeah, they're asking for the SI unit, okay, for power. Definition of power and then SI unit for power. Okay, so it's actually watts. And it's actually the rate of energy conversion. Energy converted into other forms of energy. Electrical energy converted to other forms of energy. All right, yeah. So that is the standard, as you see, right? Yeah. Standard definition for power. Quite straightforward. So let's go on. Now, which circuit can be used to find resistance of resistor R? Right, so we are actually following Ohm's law, right? Okay, so there's a way to connect. So this is the formula you're going to use. So in order to calculate resistance, you need to be able to measure potential difference across resistor R and the current that is flowing in the circuit. All right, so how do you connect the various voltmeter as well as the ammeter? To find current, we use the ammeter, right? So how is the ammeter connected?
Series.
Okay, good. In series in the circuit. Then to find potential difference, which is the voltage that we are looking for. Okay, voltmeter is connected. All right. Sometimes you can say in parallel, but I find it better to say that it's connected across. Okay, the component you are trying to, or shall I just put involved? Okay, so that component involved in our calculation, involved in our question. So this case, we are looking at the resistor R. We want to find resistance, right, of resistor R. That means we are going to connect the voltmeter across resistor R. So have we got the answer? Let me see. I haven't really looked at all your answers yet. Anaki. Anaki is not here. Krishna is here. It's here. Okay. That's all. All right. So actually, no problem. I think, Kiran, you made a mistake here, right? Yu also. Yeah. Kiran and Yu, you need to respond so that I know that you're here. Kiran is taking his dinner. Okay. Yeah. Okay. Thanks for typing in. Now, Yu, you take a look at your answer. You actually chose B, right? Okay. Now, if you're going to connect your voltmeter like this, in this manner, you're not going to get any reading, no? Clear? In order to find potential difference, the voltmeter must be connected across. This is the meaning of across. So one point here and the other point here. And you have to ensure that for the voltmeter, right, this terminal should be the negative terminal because negative connect to negative, then positive, right, going this way connects to the positive side, like this. Same goes for the ammeter. Okay, ammeter. Look, you can go this way, I think easier. So your positive terminal of the ammeter must be here. Negative terminal will be here. Clear? So once you get the current reading and also the potential difference reading, which is the V voltage, you can calculate resistance by putting in the values. Okay? Yeah. You see, understand so far? I think we went through this quite a few times already, how we connect the voltmeter and the ammeter. Okay, next. Question 3. This is the circuit. It contains 3 batteries. All right. Again, this is one battery consisting of 3 dry cells. Have to be very careful here. Okay, so now take a look. 2 identical lamps are connected in series. So these are the 2 lamps, right? And then it says that A1 equals to A2 equals to 1 amp. That means this is 1 ampere and this is also 1 ampere. As you can see, the series circuit over here, if you can't tell easily, let me show you. Notice how the voltmeters are connected to measure potential difference across each of the components, right? But then the ammeters are connected in series. The yellow loop here is the series circuit. These are externally connected just to measure potential difference. Okay, just to measure potential difference. Okay, so take a look here again. What do you remember about our last lesson? We calculated something, right? And then Haresh also noticed that he can just take the EMF minus away one of the potential difference to get the other one. All right, now, for example, if this is 6 volts, and then I calculated that this is 1 volt, what would this be? This will be 5 volt. Remember now, Haresh? Okay, we did the separation calculation separately, and then you notice that they are related this way. So try to recall that. Which statements below are correct? Okay, electric current in series circuit is different at every point. It's not true. We tested also using FAT. Harini, we tested using FAT actually. We were trying to measure current all over. Did you see the recording? No, if you have seen lah. Okay, you won't look at it now, but when it comes to your assessment, you probably will refer to it. Okay, so it's not different. It should be the same. That's why this is the correct statement. Potential difference across each component is equal to the voltage of the power source. It's not true. If this is true, then V equals to V1 equals to V2. This is definitely not true, okay? For series circuit, you need to know that the potential difference is actually this. Okay, potential difference of the first lamp and then the second lamp will add up together to be equal to the voltage across the power source. All right. Therefore, answer is D. Two person got it right. Haresh, you got it correct?
I messed up on that one. It was a careless mistake.
Careless mistake. Yeah. Okay, just have to take note. V over here, okay, this V over here is actually V1 plus V2. And you can see they tell you that V2 is 3 volts, right? And then V1 is also 3 volts. They add up together to give 6 volts. Can you see that? Okay. 6 lamps are arranged in 2 different ways in circuits X and Y. Lamps in circuit are arranged in parallel And then the lamps in the next circuit have a total resistance greater than the resistance of one lamp. Okay, so what do you think is the answer? Question 4. Wow, everybody put the same. Very good. Okay, question 4, answer is B. That's right. How do you know that X is actually arranged in parallel? Why is it not series? What gave you the hint, Harini? We don't have many people here. Okay.
The wire connecting the
wire that's connecting. Okay, what is this indicative of? Do you see this part here? What were you thinking when you saw this?
It was like I don't know.
Like jumping across it. Okay, so that means if let's say this is the wire, then there's another wire across it, not touching it. Correct? So it's like a parallel arrangement. Okay, good. Yep. So that can be it. Okay, whereas this is very obvious to be, okay, in series, right? Because the wire is connected this way. Okay. So it's like there's a connection. So it goes in. Remember what I said about series circuit? If you can use your pen to draw a loop without lifting it all the way, okay, and then this is to the power source, right? Then that means it's in a series, okay? If you can use your pen to draw a complete loop without lifting your hand, okay, then it is arranged in series. Question? No? Next one, question 5. Which of the following does not reduce? Okay, so there's a does not here. Energy wastage. Yeah, this one everybody got correct also. Okay, opening the fridge door more often to cool the room. How many of you will try to open the fridge door to cool yourself down? I mean, when I was young, I do that when the weather is very hot. Okay, but as I get older, I don't do it. Harish, you do that also, huh? Just to get a quick aircon, right? Yeah, also to get cold water as well. Okay, yeah, that's what we will do. But actually, it's really not advisable. Do you know each time you open the fridge door and the cool air comes out, when you close the door back, it takes a lot of electricity to actually get back to the temperature you set it at? Yeah, it takes a lot of electricity to do that. Okay, so the more, or shall I say, not more time, the longer you open the fridge door, okay, the more energy will be used up later on. All right. An electric cooker is rated at 240 volts, 3000 watts. If I didn't remember wrongly, in primary 6, you did go through a little bit about energy consumption, and your teacher asked you to bring along, okay, the electrical bill from home. Did you all do that? You all didn't? Okay, I did that for my classes last time, okay, to teach them how to read how much consumption of water and electricity that they actually have. So sometimes I even see 3-room flats, right? They are paying more electricity than a 5-room. Okay, because they turn on the aircon almost the whole day. Yeah. Okay, so if you are comparing the electricity consumed by the aircon unit, okay, to a fan, then you will be able to tell, okay, after you run it for a week, then you can make the comparison very easily. Okay, so this is the power rating, okay, 3000 watts. What is the meaning of this power rating? Do you all understand this part? This is the power rating of the appliance. All right. So let me tell you, okay, if it's 1 watt rating. You know what it means?